the absolute values again. But other than that, you probably won't see absolute values. So, but you'll need them in calculus. So absolute values. So we're going to do two different topics in here. So the topic number one is going to be solving equations with absolute values. So solving equations with absolute values. So why do we even need absolute values? Well, we need absolute values because they talk about how far something is from zero. So the meaning behind an absolute value is it tells us the distance between a given number and zero. So it really is a measurement of distance, which is kind of a abstract concept in terms of algebra, but it's how far something is from zero. So if I ask you to find the absolute value of a -5, what that's saying is on the number line, here's 0, here's -5. The answer is 5 because it is 5 units from 0. And that's what absolute value was originally designed to tell us about. And you can use the absolute value if you're going like from here to Springs or from Springs to Pueblo. That distance is the same. The direction you're traveling doesn't impact the distance that you have traveled. So that's what absolute value is designed to do. You'll use it in a calc sequence to develop the idea of a derivative. So you'll see it in Calc 1. So what we're going to do is solve some equations that involve those absolute values. And as always, I like to give you some steps. So we'll work on listing out some steps also. So the first one we're going to solve is, and the directions are just going to say solve, the absolute value of 3x minus 1 is equal to 2. Okay, so we see a set of absolute value bars for the first time. The very first thing we want to do, step 1, so I'll squeeze the steps in over here. We want to isolate the absolute value. And specifically, I want it on the left side. The reason I want it on the left side is to help in terms of writing directions. So you want to isolate the absolute value on the left side of your equal sign. So for us, that's already been done. Our second step is we're now going to write two equations. And the reason we need two equations is that idea of distance from 0. So we know that there are two numbers that are on the same side, that are on opposite sides of 0, that are the same distance from 0. So we have to recognize that there's a positive case and a negative case that are the same distance. So equation 1, and I'm literally going to call it equation 1. So EQN's abbreviation for equation 1. What you're going to do is you're going to drop the bars. So drop the absolute value bars in your equation. So for us, equation 1 is simply going to be 3x minus 1 is equal to 2. So all I've done is taken what I had originally. I just dropped the absolute value bars. Now equation 2, what you're going to do is keep the left side. Of equation 1. And we're going to change the sign on the right side. So this is the one that's recognizing that there's something on the negative side. So for us, equation 2 is going to be 3x minus 1 equals a -2. So one recognizes that something is 2 units on the right side. The other one recognizes that it's 2 units on the left side of 0. Okay, so now that we have our 2 equations, we're just going to solve both of them. So step 3 is to solve. You solve them one at a time. Don't try to solve them at the same time. So for equation 1, we'll just move over the 1. That'll give me 3x equals 3. Dividing by 3, we're going to get x equal to 1. So there's one solution. On the other one, we'll add the 1. When I add the 1 this time, we're going to get 3x is equal to a negative 1. And dividing it out is going to give us a fraction. Nothing wrong with a fraction. We get negative 1/3. So we actually get two solutions, which is what I'm expecting because it's an absolute value. So we get both a positive 1 and a negative 1/3. Because you're solving, you can definitely check these. If I take this positive 1 and plug it back in, 3 times 1 is 3, minus 1 is 2, and the absolute value of 2 is 2. That works. We plug in the negative 1/3, 3 times that negative 1/3, the 3's would cancel, leaving you with negative 1. That's negative 1 minus 1, that's a negative 2. But the absolute value of a negative 2 is 2. So sure enough, they both work. So you get two solutions with it. So let's walk through it again. The first thing you want to do is make sure you get the absolute value by itself on the left side. You're then going to write two separate equations. The first equation, all you have to do is drop those absolute value bars and write your equation. The second equation, you keep the left side, but you're going to change the sign on the right side from the first equation. Solving both of those will give you your solution. So it's pretty straightforward. There's not a lot of ugly stuff in this. They'll try and throw you off with some fractions and so forth, but let's go ahead and do a second example. So I keep needing to try and number my examples. So that would have been example 1. We'll go on and work on example 2. I am going to go ahead and erase the whole board to give us a little bit more room. Is everybody good to go?
Yes.
Fantastic.
Yes.
And hoping my pace is a little bit slower and easier to write with. So. Okay, so example 2. Again, the directions are just going to say solve. We're going to throw a fraction into this one. The absolute value of x over 2 minus 1/3. That's all inside the absolute value, and that's going to be equal to 1. Oh. So the first step said to isolate the absolute value. Well, that's already done for us. It's the only thing on the left-hand side. Our next example, we'll do that step on. Okay, so we're going to write our two equations. I like to number them, and part of the reason I like to number them is to remind us that we need two equations. Why else would you number them? So the first one, we're just going to drop those absolute value bars. We'll have x minus 2. I'm sorry, we'll have x over 2 minus the 1/3 is equal to positive 1. Then we'll write our second equation, and I urge you to do that immediately because otherwise you're going to forget to do it. So write it immediately. So we'll keep the left side. That's the x over 2 minus the 1/3. But now on the right side, we'll set it equal to a negative 1. We're changing the sign on the right side. Okay, now we're going to go solve both of those. At this point, I'm going to treat them totally separately. We need a common denominator on the left side, so the left equation. So let's go ahead and multiply everything by 6. So what I'm going to do is write everything in a set of parentheses with a 6 out in front, and then I can come in and do my canceling. So I'm going to move over my numbering because it's kind of in the way. Okay, so when we take that 6 and multiply it by the x over the 2 and the 6 are going to cancel, leaving me with the 3. So the 3 times the x gives me a 3x. From the second fraction, I'll do the same thing. 3 goes into 6 2 times. 2 times 1 is 2. On the right side, there's no fraction to cancel, so we're going to end up with a 6. So let's walk through that again. The 6 and the 2 cancel, leaving you with a 3. That 3 times the x gives you a 3x. 3 goes into the 6 twice. 2 times 1 gives me 2. And on the right side, we just get 6 times 1, which is 6. So we'll go ahead and add our 2. That's going to give me 3x equal to 8. And then we'll divide out the 3. So x is equal to 8/3. Okay, and we'll do the same kind of manipulation on the second equation. So we're going to, again, write everything in parentheses and multiply them by a 6 because it's still a common denominator. You can kind of let the first equation be your template. We know the 2 goes into the 6 3 times. 3 times x is 3x. Same thing we got over here. The 3 times the 6, 3 goes into 6 twice. 2 times 1 is the 2. The only thing that's really changing is on the right side. Instead of a positive 6, we'll have a negative 6. And we'll go ahead and add the 2 to solve the equation. It's going to give you 3x equals a negative 4, and x equals a negative 4/3. So you get two answers, a positive 8/3 and a negative 4/3. Now, you could check both of them. They would not be nice to check because you're plugging them in and then dividing them in half, but you could check them. They'll both work if you want to check them. So, any problem dealing with one with fractions? I noticed that our textbook likes fractions. Okay, let's go ahead and do one where we have to do that step one where we need to isolate the absolute value. So, example 3, oops. We have the absolute value of 2 minus v, just to be a different variable, plus 3 is equal to 7. So the absolute value of 2 minus v plus 3 is equal to 7. Okay, so we need to do step 1. So before I can write my two equations, I need to make sure I get the absolute value by itself. It's very similar to when we had to isolate the radical as the first step. So the first thing we're going to do is go ahead and move that 3 to the other side. That's going to give me the absolute value of 2 minus the v is equal to 4. And now that I have the absolute value by itself, we'll write our two equations. So again, equation 1, you're going to keep everything, just drop the bars. Equation 2, you'll keep that left side the way it is and change the sign on the right side. So again, keep the left side, change the sign on the right side. Okay, I'm going to give you a second to go ahead and go solve both of those, okay? And then we'll come in and go back over it, but I want you to try and solve it without me. So while you're doing that, I'm going to kind of go through and mark down who's here so that I have a record of who's here. Okay. Okay, so we'll go ahead and move the 2 in equation 1 by subtracting it. That's going to give me negative v is equal to 2, and then we'll divide out the negative 1. So v is equal to negative 2. And again, we could check it if we want. We would just plug it back in. It'd be 2 minus a minus 2, which gives me a 2 plus 2, which is 4. Absolute value of 4 is 4, plus the 3, sure enough, gives us the 7. So that worked. For here, we'll do the same kind of manipulations. We'll move our 2. Negative v equals negative 6. Dividing out the negative 1 is going to give me v equals a positive 6. And again, you can check it if you want. Plug it back in. 2 minus 6 is a negative 4. Its absolute value is 4. 4 plus 3 is 7. So, okay, let's do one more before we move on to the inequalities. Hopefully that was the answer that you got when you solved them. Because on the homework, I assigned one of them that's a quadratic. So I just want to make sure you can handle that quadratic one. So let's solve the absolute value of x squared plus x, and then that's equal to 12. So nothing within the problem tells us to do anything differently. So we're still going to come in and do the same thing we've been doing. Let's go ahead and isolate. It's already isolated. So we'll go into step 2 and write our two equations. So equation 1 is x squared plus x equals 12. And our equation 2 is going to be x squared plus x equals a negative 12. So, okay, now each of those is a quadratic, and we know that because that x squared, that tells me that instead of trying to get x by itself, I need to set it equal to 0 instead. So we're going to go ahead and move over that 12 to set it equal to 0. At this point, you're either going to factor it or take it to the quadratic formula. This one is a nice factoring, so I'm going to factor it because it's quicker. So we need factors of 12 that, because of that minus, subtract to 1. So factors of 12 that subtract to 1 are 4 and 3. So what about the signs on them? Because the middle term's got a plus in front of it, we know the larger factor has to take that first sign. The second factor takes the opposite sign. So it gives me x plus 4 and x minus 3. We'll set both of those to 0 and solve them. We'll get x equal to negative 4, and you'll get x equals 3. And again, you can check them. If we plug the 3 back in really quick, 3 squared is 9 plus 3 is 12. Absolute value of 12 is 12. So it definitely works. Okay, let's go do the right side. the other equation. So that would be x squared plus x plus 12 is equal to 0. Okay, that does not factor nicely. There are no factors of 12 that are going to add to 1. So I'm going to go to the quadratic formula just because we need practice at it. So we'll get x is equal to the opposite of b. B is the coefficient on the middle term, which is a 1. Its opposite is a negative 1. So negative 1 plus or minus the square root of b squared, that would be 1 squared, minus 4 times 1 times 12, all over 2a, which is 2 times 1. So that's a negative 1 plus or minus. Again, clean up on the inside of the radical first. That's going to be 1 minus 4 times 1 times 12 is 48, all over 2. At that point, we can kind of see where this one's headed. Because we're on a number line, we're definitely in the real number system. No complex answers can pop out of this stuff. And we can see that in that very next step, we're going to end up with the square root of a negative number, which is no good. So this one gives me no solution. So the only answers I got were from the left side when we dealt with it as equal to a positive 12. So we end up with negative 4 and positive 3. The second equation doesn't work. It could work. It just depends on the scenario. But in this case, because we ended up with negatives under the radical, that leads me into complex numbers, which are no good. So. Okay, and that's all the absolute value equations. So now what we're going to do is we're going to take out the equal sign and make them into inequalities. So that's the second type that are in this section. Any questions about the one quadratic? You have one on the homework, I think it is. Great. Okay, so solving, so this is type 2. Solving absolute value inequalities. Okay, so we're going to write steps out again. They'll be very similar to the last set of steps. Let's come in and solve the absolute value of 3t minus 2 is less than or equal to 7. So the absolute value of 3t minus 2 is less than or equal to 7. Okay, so again, the first step is to isolate. So step 1, isolate the absolute value. Okay, which is already done for us. So step 2, we're going to come in and write 2 inequalities. Let's say write 2 inequalities, just like we did last time. There's nothing really different yet. So you'll have inequality number 1, which you're going to keep the same as the original, just drop the bars. So same as original. Drop absolute value bars. Okay, so for us, and again, I will number it, that means that our first inequality is just going to be 3t minus 2 is less than or equal to 7. So it's the same as the original, all we did is left off those bars. Okay, the second inequality, this is where it gets a little bit more difficult or different. So you're going to keep the left side, just like we did last time. This time we need to flip the inequality. And change the sign on the right. So, okay, so that means for our second inequality, we're going to keep the 3t minus 2. Instead of a less than, we're going to make it a greater than or equal to. And instead of a positive 7, we'll make it a negative 7. So we kept the left side, we flipped the inequality, and we changed the sign on the right side. So again, you're still recognizing one's a possible case on the right side of 0, one's the case on the left side of 0. But you have to keep the inequalities going the same way, since this one is pointing towards the 7. This one needs to point away from the negative 7. So that's what we're doing. Okay, solve both of those. So step 3 is to solve. So when I'll solve those, same as normal, we're going to add the 2. That'll give me 3t is less than or equal to 9, and then we'll divide by 3. So t is less than or equal to 3. On the other side, we'll move the 2 also. This time we're going to get 3t is greater than or equal to -5, and then we're going to divide by that 3. So t is greater than or equal to -5/3. So again, you'll see fractions popping in quite a bit. So we've solved it, but now we need to interpret what's going on. So what I honestly recommend you do is now we're going to take those solutions and take them to a number line. So we're going to graph on a number line. That's to help me understand what's going on. So I don't want to get too low on my board. Okay, make sure you put your 2 numbers in numerical order. So I have a -5/3 that's on the left side. I have that +3 that's on the right side. In terms of the inequality statements, because they both have an equal to, that means we'll need a closed symbol on both of them. So I'm going to put a closed circle on both of them. Okay, this says that t is smaller than 3. So numbers that are smaller than 3 are to the left of that 3. The other inequality statement says that t is bigger than -5/3. Well, that would be numbers to the right. So we can see that the 2 inequalities are pointing towards each other. So we're going to trap the 2 answers between those 2 numbers. So your graph is going to look like that. Hopefully that makes some sense. Again, we're going for numbers that are less than 3. That would be to the left of 3. But we also need answers that are bigger than that -5/3. So that would be to the right of -5/3. So our 2 answers are between -5/3 and 3. And then your last step is to write the answer using the interval notation. So we're going to use interval notation. And again, I apologize, that was yesterday's lecture. So if you don't know interval notation, I did go over it, but make sure you look at that YouTube video. Okay, so then what's our final answer going to be? I'm going to take it clear up here because I need the room. So because of the closed circle and the -5/3, we're going to start off with square bracket. We'll put in our -5/3, and then it goes up to 3. And because there's a closed circle on 3, it's a square bracket. So the answer then is -5/3 inclusive with a square bracket to 3 inclusive with the square bracket. And that's how our answer is going to get written. So, and there it is. So let's walk through it again just to make sure we're on board. You're going to write the 2 statements again after you've isolated the absolute value. The first statement's the same as the original. The second statement, you're going to flip the inequality and change the sign on the right side. You'll solve each of those. Once you've got them solved, you're going to go to a number line. And that's just to get a handle on what the answer looks like. And then you're going to use the number line to write your interval notation. So also pretty straightforward. They won't get too ugly. Let's do some more of those. Any comments or questions on the steps? Because I'm going to erase those steps to get the next example on the board.
I'm okay.
Yay! Thank you, Rich, for replying. It really does help when I know that there's somebody out there as feedback. So. Okay, so this time we had a less than on the first example. We're going to go do a greater than. So let's come in and solve. The absolute value of x plus 4 plus 3 is going to be greater than 5. So the absolute value of x plus 4 plus 3 is greater than 5. So this one we do have to do that first step. We're going to come in and make sure that we move the 3 to the other side first. So we have to isolate before we can go to our 2 statements. So we'll go ahead and move the 3 over. That's going to give me the absolute value of x plus 4 is greater than 2. And now that I have the absolute value by itself, we can write our 2 statements. So our first statement would be x plus 4 is greater than 2. And our second statement is going to be x plus 4 is less than, because we have to flip the inequality, a -2. So now let's solve both of those. So for the first statement, we'll move the 4. That's going to give me x is greater than a -2. And when I move the 4 on the other inequality, I'm going to get that x is less than a -6. So I have 2 answers, but I need to interpret them. And so to help me interpret them, I'm going to go to a number line. It's the only way to make sense out of those 2 answers. So on the number line, in numerical order, we're going to put the -6 to the left. We're going to put the -2 to the right. We know that because the inequality statements do not have the equal to, that they're exclusive, meaning we don't want to include the -6 and we do not want to include the -2. So we'll use open circles to indicate that. Okay, now we'll tackle what's going on. So the first statement we got so that x was bigger than -2. So numbers that are bigger than -2 are going to point to the right. The other statement tells me that x is less than a -6. So numbers that are smaller than -6 are to the left. So instead of them pointing towards each other, they're pointing away from each other this time, which is okay. That's actually because it's a greater than clear back up here. So less thans will always point towards each other, greater thans will always point away. So for us, what are we going to write as our answer? Well, because the answer shows, or sorry, because the number line has two separate pieces to the answer, we're going to need an interval for each of those pieces. So for the first piece, we're going to go from -infinity to -6 with parentheses on everything because of the open circle. And then for the second piece of the graph, we're going to go from -2 to +infinity with parentheses everywhere. And then if you remember, the symbol that goes between the two is a U, which stands for the union. And that simply means everything in both sets. And I think when you type it into the MyLab Math, it automatically puts the U there for you. So you don't even have to worry about it. So we get two answers. You can check these. We didn't check the last one, but you can definitely check those. So let's just pick an answer that's less than -6. So I need a number that's less than -6. Let's use -7. So I'm going to plug -7 back up here. -7 plus 4 is a -3. The absolute value of -3 is 3. That 3 plus 3 is 6, and 6 is bigger than 5. So sure enough, it works. You can also pick a number over here on the -2 side. It'll also check out and work. So nice. Any problem with that? Okay, just a couple more. And I just want to make sure I'm handling all the possibilities that might pop in on that homework assignment or that you might have in your future. So let's do the absolute value of a -x minus 2, and we want that to be greater than or equal to 1. So the absolute value of a -x minus 2 is greater than or equal to 1. So the absolute value is already isolated. Let's just go ahead and write our two statements. So that would be a -x minus 2 is greater than or equal to 1. That's number one. The other statement would be -x minus 2 less than or equal to -1. So again, I flip the inequality and change the sign on the right. Okay, we're going to solve both of those. So we'll add the 2. Going to give me -x is greater than or equal to 3. I now need to divide out that -1. And we saw yesterday that when you divide by a negative, you need to remember to flip the inequality statement. So we're going to get x is less than or equal to -3. So again, anytime you multiply or divide by a negative, you flip the inequality. It's one of those little quirks that you got to remember. Okay. On the other one, we'll do the same kind of manipulation. So we're going to add the 2. That's going to give me -x is less than or equal to a +1. And then we'll divide out the -1. So x is greater than or equal to a -1. Okay, so now that we have our two solutions, let's take them to a number line to interpret them. So make sure you get your numbers in numerical order. Again, that always feels weird to say, but it's the number one mistake I see is that people just don't get things in the correct order. Okay, so on both of these, because of the equal to on the inequalities, we're going to use closed circles. So closed circle on both. The left one is saying x is smaller than a -3. So all numbers that are smaller than a -3 are to the left. This one's saying that we need numbers that are bigger than -1, so that should be to the right. So it looks like that. And I know just a few minutes ago I said that when you have greater thans, they should do this, and when you have less thans, they should do that. The problem here is that negative on the inside of that absolute value is impacting those inequalities. So as always, take it with a grain of salt. We still need to write our answer. So our answer using interval notation, for the left side, we're going to go from -infinity to -3, this time with a bracket because of the close. And then union, we'll start with another bracket at -1, and go off towards infinity. So there's our final answer using interval notation. Again, interval notation is so important moving forward. We're going to write intervals in the future with increasing and decreasing. We'll use it in quite a few different places. So it's handy to get used to it now when it's fairly straightforward on what we're doing. Okay, you guys are doing good, I hope. Okay, and then, as in all things, there are the ones to watch out for. So I've kind of grouped these all together. So these are the ones that I like to say caution. Okay. And what we're going to say is watch out for negatives on the right side. So these are the ones where the author of the book is trying to trick us. Don't fall for it, is all I'm saying. So for instance, you might have something like the absolute value of 2 minus x is equal to a negative 1. So the absolute value of 2 minus x equals a negative 1. And I want to solve that. So you could go through the mechanics of what we just talked about. I could write my two statements. Do you want me to do it wrong and then show you why it doesn't work, or just explain why it's not working?
I'd say explain why it's not working.
Okay. So it's this right here that's going on. So remember that this is the distance from 0. How can I be a negative 1 unit away from 0? Distances are never negative. So anytime there's a negative on that right-hand side with an equal to, we know that it's a no solution. So we can't be a negative distance from 0. So in this case, the answer is going to be a no solution because of the negative. So you have to be really careful about it, because you will solve it. You'll write your 2 equations, you'll solve it, you'll get 2 answers. But if you check them, they will not work. So be very, very careful anytime there's a negative on that right-hand side. Okay, so there it is with an absolute value equation. What about an inequality? So what about the absolute value of 6x? And we want to say that that is greater, no, let's do less than negative 2. Okay, so let's think about what this is saying. This is saying you're taking the absolute value of something. You're looking at the distance from 0, and it needs to be smaller than a negative number. Well, the distance can never be smaller than a negative number. The distance can never be less than a negative number. So in this case, again, we get no solution. So is there ever a way that you could have an absolute value with a negative number where you would get a solution? Well, yeah. What if I threw a greater than in there? So as our last comment, let's take a look at the absolute value of 3x plus 2 is greater than negative 5. So the absolute value of 3x plus 2 is greater than a negative 5. And it doesn't matter whether it's a greater than or equal to. It's the fact that we're comparing that distance to a negative number. So won't the distance always be greater than a negative number? Even if the distance is 0, it's still going to be bigger than a negative number. Okay, so what is that really saying is our answer? Well, this is saying that you can pick any number you want and plug it in for that x. Plug in a 5. We'll plug in 5. 3 times 5 is 15. Plus 2 is 17. The absolute value of 17 is bigger than a negative 5. Let's plug in a negative number. So let's plug in a negative 1. 3 times negative 1 is negative 3. Plus 2 is 1. A negative 1, sorry. That absolute value is going to be 1, which is always greater than a negative 5. So no matter what number you plug in, even if you want to plug in a fraction or a decimal, you're still going to get answers that work. So in this case, the answer or the solution is going to be any number. Okay, well, that's not a very mathematical way of writing that. So we usually write it as negative infinity to infinity. So basically saying you can use any number you want and those numbers will work. So anytime you have a greater than a negative number, this is what we're going to have. If you have less than a negative number, it's no solution. If it equals a negative number, it's a no solution. So those are the kind of the tricky ones that the author throws in spots for you to double check things on. So, okay, and that should get you through the rest of the homework for this week. Again, your deadline is due on Saturday, so at 11:59, and then the quiz is due on Sunday. So homework due on Saturday, quiz due on Sunday at 11:59, and then Monday we'll start the whole thing all over again. Any other questions or comments?
No.
We're good to go?
Yes, I'm good.
Yeah.
Yay!
Yeah.
Okay, so if you have a question about past homework or anything, you can go ahead and stick around. Otherwise, I'm going to stop my recording and go have a wonderful day.